so many decisions, and simulation, along with its correlative and auxiliary analytical methods, can help with all of these and many more. Staffing, equipment, all of these, maintenance policies, perhaps less obviously inventory policies, and so many objectives. Keep your equipment utilization high. The equipment costs you a lot of money. Likewise for the workers, short waiting time, length of queue, time in queue. Keep the inventory low, but well, we don't want stockouts very often either. Rare and short downtimes. It's nice if they're both rare and short. And so many interactions. This is where simulation really comes into its own. All of these pairs have a nasty habit of contradicting each other. We want both, but typically, if you do really well on one, it becomes harder to do well on the other one. These 8 pairs are the most notorious in actual management work and management headaches. Excedrin headaches number 1 through 8. And there's more besides these, but these are the most conspicuous ones. So what's a manager to do? Yes, what's a manager to do? Well, we have an arsenal of tools here at PMC, quite a big one. And here's some of the things in our arsenal. Now today we're looking particularly at simulation modeling. It's very useful to build confidence intervals for performance metrics or test statistical hypotheses, regression analysis, and I don't mean just linear, there's many other kinds. Regression analysis can unearth and interpret interesting relationships between variables. If one of the variables is points of time, like weekly, monthly, as it often is, then time series analysis takes over where regression analysis leaves off. The next two, ANOVA and DOE, as they're nicknamed, actually go together. DOE helps design experiments, build on the principles of looking at where your variability comes from. Which alternatives among many, ANOVA and DOE can examine dozens of possible alternatives very efficiently to help choose the best one. And ultimately, you can come to perhaps the most sophisticated of all, various search methods for optimizing system performance. And optimizing system performance might be optimizing in a weighted sense, where many of those objectives, like short queue lengths, high equipment utilization, and so forth, are weighted in terms of a management judgment call of their relative importance. Now, simulation is really good for sensitivity analysis. And the second bullet on this slide indicates exactly what sensitivity analysis does. Where should we put our money in order to improve the system? We might want, as shown here, a 10% improvement in one or several KPIs, key performance indicators. Jobs per hour is one of the most obviously important. Queue length, inventory level, equipment utilization, rarity of stockouts, and so forth can be other key performance indicators. So what should we do? Where should we put the investment? Or, and then there's all those question marks at the end. Let's not forget, maybe another one is more worker training, higher expertise among the workforce. And simulation is very good at looking at interactions. The previous slide illustrated some of the very possible ways likely to be suggested in the executive conference room for improving system performance. And it may very well be true. In fact, it's more often true than not in my experience, which goes back 35 years. Well, don't gasp, I'm 72 years old. You can't see how old and gray and wrinkled I am over the webinar. But very often, one suggestion won't help much. And then someone makes another suggestion, and that won't help much. But just maybe implementing both of them finds a synergy, an interaction, and the two of them together produce a very significant improvement that you'll be very happy to see. And when simulation and output analysis of the simulation, often undertaken with DOE, work together, it's much easier, not trivial, but it's much easier to find those synergies. That's really where the added value of simulation analysis and its related methods that I've been mentioning along with it can really help improve your system. And there might be many such synergies, and computer simulation can explore a good many of them concurrently, hence efficiently. Well, let's have a little tiny demo, just a very tiny one. I'll leave the show for a moment. We'll pick it up, and I'm going to open up. Now, there's a simulation model in one of 8 or 10 of the software packages we use. The particular software package used here is a good one. No reason to emphasize it. There's many other good ones. But the point of the demo is, now a model doesn't get any smaller than this. Customers, they might be parts, patients in a clinic, people registering at a hotel, parts arriving at a machine, ships arriving at a port, trucks arriving at a warehouse, and so forth. Customers come in, they get served, and they leave. And we could run this little model. The animation goes right along with the model. You can see lineup. Green means it's busy. Then the customers leave. If you want 3D, that's just a click away with modern software packages. And the model can, under the run, be fast-forwarded. And you specify how long it runs. Wow, we got 24 hours of simulated experience in 4 or 5 seconds. Well, it might take 4 or 5 minutes for a big life-size model. But even more importantly, what are all the different things we could do? These might be called scenarios. That's what this software calls them. What if the number of arrivals got lower or higher? We could put that one in too. What if the server had to slow down? That's the day the inexperienced worker is on duty. Or what if the server got faster? We invested in training of the worker who's providing the service, or invested in a faster machine, or downtime increased according to these numbers. Or, happier thought, you put in another scenario, downtime decreases. And you get responses of interest, like average line length, average waiting time, and what you might call throughput, JPH, total jobs served, and you run the experiment, chugging along. Useful results like this are worth waiting a bit for. And there you get some very interesting performance metrics, and you can easily get more. Average line length, average waiting time, move that aside a bit, total number served. These are averages over the number of replications. It's important to run replications because there's randomness in the model. That's one of the marvelous capabilities of simulation. It can simulate randomness of events, like exactly when the customers are going to arrive or exactly how long their service will take. And these results can then be exported to statistical methods and software like analysis of variance and design of experiments, and more scenarios can be defined. Like we have a faster service and a lower downtime. How much improvement would the two together make? If you were to invest in a faster machine that also was more reliable, maybe because it's newer, maybe because maintenance methods have been strengthened and followed with more rigor. So there's a little example, demo model of what simulation can do. So you've seen a little demo, and that's just an enticement. And beyond the demo, what would be some real-life examples? And all of these, I've managed to fit 8 on the slide. All of these, and I've deliberately picked a big variety of application areas. All of these are projects I've actually worked on in the last 8 or 10 years, along with many others. But these are some of the most interesting and most highly varied. So you can see healthcare, that's become a major application of simulation, inventory policies, plant floor layout in the machine shop, improving the automotive service garage, that was largely a matter of worker cross-training. Simulation proved it would be very helpful. Automated car parking system. Exactly how should the automatic car parking be instructed to look for places to park the next car coming in? Bus routes. Public transport is a very fruitful area in which to use simulation. Staffing levels at a service industry, in this case a takeout restaurant, and improving the machining and the material handling. That would involve the forklifts, the tugger trains, the automatic guided vehicles, and so forth in use of the warehouse. And indeed, on our website, there's a history of many projects, applications of simulation, and the other things in the list of things we do relative to projects we've undertaken.